So this problem involves part projectile motion. And what I'd like to do is actually show you how to use the projectile motion for formulas to solve problems where you don't have all the data. So first, let's get the hang time. So the hang time is in fact v naught sine theta divided by g times 2. And in this case, that's going to be 2 times 42 times root 3 over 2, because that's the cosine of 6, or the sine of 60, divided by 10. And when I simplify all that out, I'll just get the total hang time here in a second. I'm hoping it's bigger than 5.5 seconds. That would be helpful, right? So here we go. We got 84. Whoops. So we got the sine of 60 times 84 divided by 10. And that's giving me 7.3 seconds of hang time. So let's be clear right here. We've got 2.5, so when we are right here at this height, maximum height, 2.75 seconds have elapsed. Okay. And if this were to hit the ground here, it would take a total of 7.3 seconds. So actually, let me say that one more time. If we launched this in the air and it landed all the way here, the total time would be 7.3 seconds. Only halfway up means that right here, if we take 7.3 divided by 2, that's going to be 3.65 seconds at the top. So what I'm going to do is this. I'm simply going to solve vertically for part A, and I realize that the time when it hits point capital A is 5.5 seconds. That means the time to fall is 3.65. Sorry, is 5.50 minus 3.65 seconds. So what that means is it's going to take this about, I believe, 1.86 seconds. Let me just calculate that one. So 5.5 minus, 1.85 seconds. Okay, to fall from the top all the way to this point A. So let's just see the distance that it falls. So the distance it falls is, the falling distance is 1/2 gt squared. That's going to be, it falls 17.1 meters. Let me just double check that. Yep, 17.11 meters. Now let's get the total height. The height is v naught squared sine theta all over 2g, sine squared theta all over 2g. So that's going to be 42 squared times 3/4, that's sine 60 squared, divided by 20. So that's 66.15. That's the total height. So little h is going to end up being h minus the amount we fall, which is going to be 49.04 meters. So that's part A. For part B, the speed of the bone just before impact at A, so we can do Vy as gt plus 0. and we're going to use that falling time. So it's going to be 10 times 1.85, so it's going to be 18.5 meters per second. And in the horizontal direction, its speed is 42 times the cosine of 60, which is going to be 21 meters per second. So the speed is going to be vx squared plus vy squared under a square root. And when we get that, that ends up being 27.99 meters per second. And sorry, I'm going to move that to here. (18.5 squared plus 21 squared to the 1/2 just squared. All right. And then for part C, the maximum h reached above the ground, we got that right here. So that's 66.15. All right, so that is problem number 2.